6.6 goes over geometric sequences. When you have a geometric sequence, you have a common ratio that's happening. So you are multiplying by something in order to get from one term to another. If we look at example 1, we're determining whether each sequence is an arithmetic sequence, a geometric sequence, or neither. If we have an arithmetic sequence, remember we are adding something in order to get to the next term. Geometric, we are multiplying by something to get to the next term. For example A, we're given the numbers 120, 60, 30, and 15. Well, if we multiply from 120 to 60 by 1/2, we can do that. Then to get from 60 to 30, we multiply by 1/2. To get from 30 to 15, we multiply by 1/2. So this is a geometric sequence. For example B, we have 2, 6, 11, and 17. From 2 to 6, we can multiply by 3 or add 4. From 6 to 11, we can just add 5. So from 2 to 6, we're going to add 4. From 6 to 11, we add 5. From 11 to 17, we add 6. So because we're adding a number each time, however, it's not the same number that we're adding each time, this one is neither. For example C, we have 5, 1, -3, and -7. So from 5 to 1, we can subtract 4. From 1 to -3, we can subtract 4. From -3 to -7, we subtract 4. So because there is a common difference here that's happening, we are looking at an arithmetic sequence. For example D, we have 1024, 128, 16, and 2. So for this one, if we take that 1024 and we divide it by 8, so we're multiplying it by 1/8, we get the 128. If we multiply that one by 1/8, we get the 16. And if we take that one and multiply it by 1/8, we get the 2. So with this one, because we're multiplying it by that fraction, we do have a geometric sequence. For example E, we have 2, 6, 10, and 16. So from 2 to 6, we can add 4. From 6 to 10, we add 4. From 10 to 16, we add 6. So yes, we add 4 for the first two, however, the next one we added 6, so this one is neither. And the reason why I did not multiply these by anything is because to get from 2 to 6, it's times 3. But from 6 to 10, it's not multiplying by 3, so that automatically rules the geometric out. So the next part of your lesson goes over extending that geometric sequence. So we're asked to write the next 3 terms of each of these geometric sequences. We got to find that common ratio in order to extend this for the next 3. So if we look at example A, we have 3, 6, 12, and 24. From 3 to 6, we multiply by 2. From 6 to 12, we multiply by 2. From 12 to 24, we multiply by 2. So 24 times 2 gives us 48. 48 times 2 gives us 96. And 96 times 2 gives us 192. So the next 3 terms within that geometric sequence are just the 48, the 96, and the 192. For example B, we're given 64, -16, 4, and -1. To get from 64 to -16, we'll divide by -4, or we can say that we're multiplying by the -1/2, or 1/4, I'm sorry. From -16 to 4, we multiply by -1/4, and from 4 to -1, we multiply by -1/4. So if we take that -1, we can put it over 1. We're going to multiply it by negative 1/4. This gives us a positive 1/4. So that's our next term. That 1/4 we multiply then by negative 1/4. That gives us a negative 1/16. Then we can take that negative 1/16 and multiply it by negative 1/4. And that gives us that third term that we're looking for 1/64. So those next three terms are just 1/4, negative 1/16, and 1/64. For example C, we have 80, negative 40, 20, negative 10. So to go from 80 to negative 40, we multiply it by a negative 1/2. To go from negative 40 to 20, we multiply by negative 1/2. From 20 to negative 10, we multiply by negative 1/2. So again, I'm going to take that first, or that last number that I see there, which is that negative 10, and I'm going to multiply it by negative 1/2. This gives me a positive 5. Next, I'll take that 5, turn it into 5/1, and multiply it by negative 1/2. 5 times negative 1 is negative 5. 1 times 2 is 2, so it's negative 5/2. Next, I'll take that negative 5/2, and I'll multiply it by negative 1/2. A negative times a positive isn't positive. A negative times a negative is a positive. 5 times 1 is 5. 2 times 2 is 4, so that's 5/4. So 5, negative 5/2, and 5/4 are all those three numbers that we need to find. For example, D, we have 2,500, 500, 100, then 20. So to get from 2,500 to 500, we're going to multiply by 1/5. To get from 500 to 100, we're going to multiply by 1/5. To get from 100 to 20, we multiply by 1/5. So we're going to take that 20, we can put it over 1 and multiply it by 1/5. That's just going to give us 4. Then we take that 4, we can put it over 1 times 1/5. That gives us 4/5. Then 4/5 times 1/5 gives us 4/25. So 4, 4/5, 4/25 are the next three terms in that sequence. So the next part that we're going to look at goes over this formula that you see here. This a sub n is equal to a sub 1 times r to the power of n minus 1. This just means that a sub n is the number of the term that you're looking for, is equal to a sub 1 is the first term in the geometric sequence, times r, which is your ratio, common ratio, raised to the power of n, which is the number of the term you're finding, minus 1. So if we look at some examples, it tells us to write an equation for the nth term of each geometric sequence and to find a sub 7, which means we're just finding the 7th term in the geometric sequence. So using that formula, we said we have a sub n is equal to a sub 1 times your rate raised to the power of n minus 1. So if we look at example A, we have 2, 12, 72, 432. From 2 times 12, we multiply by 6. From 6 to 72, we multiply by 6. From 72 to 432, we multiply by 6. So giving us that geometric sequence equation, a sub n, we're finding which term? The 7th. So we're going to do a to the or a sub 7 is equal to a sub 1. What was the first term? The 2. So 2 times your common ratio, which in this case is 6, raised to the power of n, which is 7, minus 1. You can simplify that 7 minus 1 up top. So it's just going to be a sub 7 is equal to 2 times 6 to the power of 6. With this, you would have to simplify that 6 to the power of 6 first. You would get a sub 7 is equal to 2 times 46,656, and then you just multiply that by 2, and you get that a sub 7, so your seventh term is equal to 93,312. So for B, C, and D here, we're just going to give the equation for the geometric sequence. So for B, we have 1, negative 5, 1, 25, negative 125. So from 1 to negative 5, we multiply by negative 5. From negative 5 to 25, we multiply by negative 5. And from 25 to negative 125, we multiply by negative 5. So our R term here is negative 5. Your a sub 1 is the first term in the sequence, which is 1. So we're going to plug these values in to a sub n is equal to a sub 1 times r to the power of n minus 1. So this is going to give us a sub n is equal to 1 times negative 5 to the power of n minus 1. And you're going to leave it just like that. For example C, we have 13, 26, 52, and 104. To get from 13 to 26, we're going to multiply by 2. 26 to 52, we multiply by 2. 52 to 104, we multiply by 2. So R is 2. A sub 1 is the first term, so that's the 13. So again, we're going to use a sub n is equal to a sub 1 times r to the power of n minus 1. So this is going to give us a sub n is equal to our first term, which is 13, times our common ratio, which is 2, to the power of n minus 1. For example D, we have 432, 72, 12, and 2. To get from 432 to 72, we're going to multiply this by 1/6. From 72 to 12, we multiply by 1/6, and from 12 to 2, we multiply by 1/6. So our ratio, our R, is 1/6. Our first term is the a sub 1, which is 432. And again, we're going to use a sub n is equal to a sub 1 times r to the power of n minus 1. So plugging these values in, a sub n is equal to 432 times 1/6 to the power of n minus 1.